So in this lesson, we're going to talk about baking lights and light map resolution. Baking your lighting is an amazing way to get great looking results and keep your work efficient and your frame rate high. So we need to first define baking. So what is it? It's calculating the light results ahead of time and putting the luminance and directional value information into material maps that are stored in the game. So in order to get good quality baked shadows, you need to have enough resolution to present them in your light maps. So what is that? The light maps are information that's stored and that's connected to each of these static meshes. So when you bring in a static mesh, we've talked about a little bit that you have the choices of setting up your light map resolution, or you can even do your light map and set it so that it imports externally. However, in Unreal, so I'm going to hit Control B to select this mesh in the editor. I'm going to double click to open up the static mesh editor, and we'll take a look at the UVs. The light maps are usually stored in UV channel 0, and also let's look at where the light map resolution is. So under General Settings, Light map resolution, the default here of 64. Now let's see how that looks in Engine. Is 64K enough? Well, how do we know? Well, the goal is to create a consistent texel density. I have a slide for that. Let me pull that up. So light map density. You want to create consistent shadows for your level. And the way you can see this is that there's a tool. Using hotkey Alt-0, you can pull up the light map density view mode, and quoting some of the Unreal docs here. The light map density color codes based on the relationship for the ideal versus maximum impact on your game in terms of hit and texel density. The goal is basically you want to see green, which would be the ideal texel density. So let's take a look at where we are in this level that I've built. Now I've purposefully built this with inconsistent texel density so we have a chance to fix it. So I'm hitting Alt-0, and whoa, look at that. We got everything from red to green here to somewhere in the middle. So now if you remember, green is pretty much ideal, red is too much, and blue is somewhere a little bit light. So let's fix those. So this one I've set at, so hit Control B, and there's two ways to set up the light map resolution. One is you can set it in the static mesh editor, right? You set it when you bring in your meshes, but on a case-by-case basis, you can also select the object in Scene and override it. So that's what I've done here. But seeing as this is used multiple times, we might as well just set it once. So let's just double click here. We'll go back to where we were under Light Map Resolution General Settings. We'll dial in 128. We'll hit save. And now let's take a look. Hey, that's looking a lot better. Great. So now let's select these. And what I have here is I've set this to too large of a number. So let's Control B, go in, and we'll try a couple different resolutions and see what will fit in terms of making this green. So we'll scroll down to General. Let's try half, so 512. And we're getting there. It's lighter. Let's half that, 256. Hey, there we go. That's looking nice and green. All right, looks like we've got just one or two more issues here. So got this one, so I'll hit Control B again in the browser, open it up, scroll down. We're at 512, so I think we came up with 256 was a good number for that. Yes, and this last one here, what have we got here? Oh, we overrode the resolution, so let's just do 28. See if that was enough. Maybe we can do double, 256. And what about the ground plane? Now the ground plane is really a large piece here. So even at 1024 it's not quite enough. So if we double that, 2048. How are we doing now? Yeah, we're just about there. For now, I'm going to leave that. And we're going to go to my light baking checklist. So what are the things that we want in order to get our lights looking good? In addition to making sure that you've got a light mass importance volume, if you're doing an interior, you can add a thing called a light mass portal. If you have skylights that you want to have light coming through a window, it will generate additional light rays for that light mass portal. And it's a common thing that I've seen in other 3D packages for efficiencies. So also double check to make sure that the lights you have set, if you want them stationary or static, make sure you have them set correctly. So double check all your lights. The next is to go into world settings. Now in world settings is where there's a lot of settings that can connect to light mass, global illumination. And some of these you're going to have to change based on what specific results you need for your specific level. What do I mean by that? Static lighting level scale, if it's lower than 1, then you are going to get a lot more details, which is good, but the more details that you're evaluating, obviously the higher cost. So also the number of indirect bounces as light bounces around your scene, 3 to 5 is usually good. The default is set at 5, and that's where we have it set for this. The number of skylight bounces. Now, this used to be static, but they've recently allowed you to additionally allow the light to bounce from the skylight. Now, if you have a really strong ambient light, then you might want to calculate additional skylight bounces. I have it set at 2 for this. Indirect lighting quality. Now, the higher the number will reduce the noise, but it increases the bake time, as well as indirect lighting smoothness. Greater than 1 will reduce noise. Greater than 1 will reduce noise, but it increases baking time. And finally, there's other stylistic choices, right? If you have ambient occlusion, now GI automatically calculates and will deliver ambient occlusion, but sometimes you want a little extra ambient occlusion, so you can turn that on and dial in certain settings to make your scene just look like the way you want it. So the final choice, right before it's in the button for baking, you can choose what quality level you want to build at, preview to production. So let's take a look at these choices in Engine. So we've double confirmed we have a light mass importance volume. Also, in this case, since we did some interiors, I added a light mass portal. You can get one of those by just typing portal up here and just dragging that into scene. Also, on our lights, we've checked to see that they are set to what we want. I've got one stationary, one movable, and one static. So under the details panel for the light, there it is. And then finally, under the world settings, this is where all those controls were that we were talking about. So we've got the static light levels, number of indirect bounces. I've got the number of skylight bounces, indirect lighting quality, and we got a pretty decent bake. The issue that we were running to before was that we had some inconsistent texel quality when we had it set to Alt 0. Well, looks like we could up this a little bit as well. So I'll just do an override on it. It's getting there. Let's see, 512. Yeah, that's pretty good. All right. So given that we've got pretty close textile density to what we want, we can do a light bake and see what we've got. So under build, and this is the lighting quality choices for preview, medium, high, and production. Now, cranking it up to production can really increase your computation time. So I will pause the video and we will come back when this is finished computing. All right, we're back and we're done baking. So everything is looking pretty good. Some of the areas that had issues are no longer a problem. I also tried in the world settings, dialing down the static light level scale a little bit to see if I could pull out a little bit more detail in some of the shadow areas. I also adjusted up the texel density just slightly in some of the areas. I'm going to hit Alt-4 to go back. Let's take a look outside. It's looking pretty nice. Got a really nice global illumination look to the level right now. All right, great. Let's flip to the slides and wrap this up. So we started by talking about light map density and adjusting our texel density, texture resolution on our meshes in our scene towards an ideal texel density using the view mode Alt-0. We went over a light baking checklist, making sure we had our light mass importance volume there. We also used light mass portals. We double checked our lights to make sure they were correctly set for light baking. And then finally, we went over some of the world settings that are inside the light mass global illumination document. And we talked about some of the cost and benefit for adjusting some of these settings for different scenes. And finally, we finished by using a production level quality build, and we didn't have any issues. However, sometimes I'm going to wrap up by saying that sometimes you are going to have light map bleeding. Typically, I've noticed it with some of my students' work where they have a roof on top of an object, and where there should be ambient occlusion, there's a rim of light. And there's different fixes that you can try. Sometimes you can just connect the meshes. Sometimes it's your UVs that the shells are a little bit too close together. Sometimes increasing the padding, especially if you've done your own UV layouts for your light maps. Typically now I use the Unreal's algorithm, and that's not a problem. Also, if you're trying to use 2D meshes, just don't. Typically those will cause a lot of problems. Also, if you have within your meshes coplanar faces, or if you have two meshes in the level that have geometry that are coexisting in the same place, that can cause light baking problems. And finally, one new solution for some of the light baking is using a mitering solution. And that was talked about in this new video on fixing light map bleeding. Actually, there's two. They're about 12 minutes in total that came out in March of 2020. So there's always a lot more that could be talked about in terms of light baking. But for now, that's going to wrap things up. I'll put additional resources in the notes section, and we'll see you in the next video on real-time lighting.